In this figure, we see the concepts of a jet, or the aspects of a jet. We have the compressor section, we have the burner section, and then the turbine and nozzle section. The diagram is a schematic of a turbojet. In larger and newer aircraft, you'll hear that we use turbofans. It's the same concept, but a turbofan uses a large fan in front of the portion of the jet engine, which is powered by the turbine. And all we're doing is accelerating the mass of air coming in from the intake, going through the compression. We burn the air, which accelerates it, adds more energy, going through the turbine section, and the velocity, exhaust velocity out the rear end of the engine produces an acceleration or force. So in both cases, the jet engine takes a mass of air, accelerates it through the core, and the air is exhausted at a higher velocity. This acceleration of air mass produces the jet thrust force. Airplanes such as the Boeing 747 can have each engine, so that's 4, producing almost 50,000 pounds of thrust each. It's quite a lot of thrust. So let's look at the differentiation between jets and props in terms of fuel flow. We can differentiate fuel flow between props and jets. We say that jet fuel flow varies with thrust. So we say that jets are thrust producers. Whereas prop fuel flow varies with power output. So we say that props are power producers. We got to look at thrust available and how it relates to velocity. There are some main differences between thrust available and fuel burn between jets and props. Typically, jets can produce more thrust than propellers. We see that. Furthermore, it is seen that the available thrust of a jet remains almost constant with increasing velocity. So, compare that to a propeller engine. Propeller engines, however, experience a reduction of thrust with velocity. We'll see that as we go faster, the aircraft can no longer, or the propeller can no longer produce as much thrust. The faster they go, the less thrust they can produce. Propeller efficiency decreases with velocity. This mainly has to do with the efficiency of the production of thrust between jets and propellers. So let's take a look at altitude, how altitude affects thrust and how it affects fuel burn. As altitude increases, we know from previous lectures that air density decreases. For both propellers and jets, that means less air mass, the density of air, is less available for thrust. So in both cases, as they go up in altitude, they lose thrust available. They cannot produce as much thrust as they can at sea level. However, let's look at it in terms of jets. We measure fuel consumption in jets as specific fuel consumption. We call it specific fuel consumption. It is seen that as altitude increases, fuel consumption decreases for jets. That's kind of interesting. Propellers, on the other hand, are power machines. They fly at a given power setting. They're kind of set in that sense. Fuel flow does not vary with altitude for propellers for a given power setting, so it doesn't really care about altitude. So we can see with these comparisons, it makes more sense for jets to fly at higher altitudes. Even though you lose a little bit of thrust, you're gaining some fuel burn efficiency. It burns less fuel. Whereas propeller aircraft do not have much of a preference with respect to altitude aerodynamically. So propellers aren't as picky with respect to altitude. So jets like high altitudes, props don't really care as much. So in closing, we discussed the various differences between jets and propellers. While they are different, they hold similar physical properties. The main aspects is they both accelerate a mass of air through its engine compartment and produces a force called thrust. We say that jets are thrust producers, props are power producers. We also looked at how altitude affects thrust and how it affects fuel flow. And we say that jets prefer higher altitudes, whereas props prefer no altitude. Doesn't really care too much about altitude. All right, so this concludes our lecture. Thank you for watching.